What about the second one? Yeah, that's just basic. We're going to do e to the x, and then we're going to do 3 sine of x. Just our basic rules, we'll do that one. What about the third one? That's chain rule, okay? We've got e and then a bunch of stuff inside of there, so chain rule. What about the next one? That's the product rule. You've got 5x times the ln of x. All right, that is the product rule. What about 4? That's the chain rule, okay? That's 4 minus x squared to the 1/3 power, so that would be chain rule. What about the next one? Chain rule, okay? Inverse cosine, and it's got that extra stuff in there, okay? So that's chain rule. What about that ln of 5x squared plus 1? Chain rule, okay? And then what about the next one? I would say basic because we could write this as 3x to the negative 4. We do not have to do quotient rule on that one, okay? So we could do basic. What about the next one? That's definitely quotient rule, okay? And the last one, that's quotient rule, okay? We would do a chain as part of it, but quotient rule's the first strategy we would employ, okay? So it's important we get to where we can recognize that, all right? So that's really what today kind of focuses on to start, okay? All right, so let's see what's down here. So here, multiple choice, it wants me to take a derivative of f ln of x. It tells me what f is, so let's think for just a second. What is it asking me to actually do in this problem? Besides take a derivative. Which method would be what it's asking me to do? It's chain rule, okay? And so chain rule says that we would take the derivative of the inside stuff. So let's do that first. What's the derivative of ln of x? 1 over x. Then I would multiply it by the derivative of the outside function. Now, we have to be careful because the derivative of that outside function is going to have stuff inside still. The inside stuff is still going to be that ln, okay? So what's the derivative of x squared? 2x. Well, my x is actually that ln of x that was inside, okay? Plus, let's see. And then what's derivative of 2x? 2. Now, be careful here because I probably should have put a bracket right there because I'm taking 1 over x times all of that stuff, all right? And so if we simplify, the x is going to stay on the bottom. The top would be 2 ln of x plus 2, which is a. Okay? So again, a little bit confusing. What do you think is the biggest mistake people make on that one?
Instead of putting ln of x, 2x.
They'll just put 2x. Yep, that is the biggest mistake because we're like, ooh, I know it's chain rule. Ooh, I know I need to do the derivative of the outside, but we have to be careful. When we do the derivative of the outside, the inside stays where the variable would be, okay? And so that's an important application there of the chain rule. Good. All right, let's look at the next one. So if the ln of 2x plus y is equal to x plus 1, then dy dx equals, what method are we going to have to employ on this one? Chain rule for sure, okay? But what's different about this one? It's not just a normal everyday chain rule. Yeah, it's implicit, right? Because that 2x plus y is inside it's inside that ln, so we would use implicit with chain. So let's walk through that one, okay? Start with the derivative of what's inside your chain. So the derivative of 2x would be 2. The derivative of y would be dy dx, okay? Then we have to take the derivative of that ln, which would be 1 over 2x plus y, equals, what's the derivative of x? 1, okay? And then the derivative of 1 would be 0. Now, the tricky part to me on this one is the simplification because I got to be able to get that dy dx by itself. Because I have a product here, 1 over 2x plus y, I can multiply that 2x plus y over to the other side, okay? And then that's going to leave me with just 2 plus dy dx, okay? So we're going to multiply each side by 2x plus y, okay? Over here, it's going to leave me with just 2 plus dy dx equals 2x plus y.
I apologize for the interruption, but if any of those names I called earlier came down but then went back to class, I need them sent back down. Or if any of those names never left your room and you remember it being called out, you can buzz the office and let us come get them or send them to the bowling alley. We feel like there's several students ignoring their name being called out.
Yep. Okay. So now to get the dy dx by itself, we would just have to subtract the 2. So I get 2x plus y minus 2, which would be b. Okay. Why's your mind blown?
Yesterday on the quiz, number 3, it was like, I kind of kept getting the same thing where it was like dy dx, it was like dy dx times x plus y. And I didn't know how to get dy dx by itself, so instead of multiplying by each side, I just divided by each side. Oh, I'm so close to getting 100 on this.
Okay. Well, I haven't graded it yet, so.
I'm so close.
There's still hope for you, Wilmer. The day it happens, I'm bringing donuts, okay? Okay. The day Wilmer gets 100, I'm bringing donuts.
I'm so close.
We should get plus 5 after school, before school, after semester.
Do we get plus 5 at the end of the semester?
Yeah.
Yes, because I've said it 100 times.
Well, it says honors.
I know, but I cheated a little bit. We just don't tell people. Shh.
Yeah, Caleb.
Oh.
Okay, because we do AP the whole time.
You're about to ruin for everyone.
Yeah. They let me. Nobody's looked yet, so.
Women, you can't say anything.
Nobody argues about extra points, so. Okay. It feels only fair to me, and Dr. Becker agrees, so. Okay. That's what matters. All right, so let's talk for a second about higher order derivatives. So when my nephew was little, they came over to trick or treat in my neighborhood, and he was probably 3, okay? And he couldn't say Halloween. He said Halloween with an ing on it. So every time we encountered somebody, every person we encountered, Happy Halloween, Happy Halloween. And he was a puppy dog. Happy Halloween. So there was this little dog saying Happy Halloween everywhere we go. Didn't just text me Happy Halloween with a picture of him. Sweet. Okay. Alrighty. So higher order derivatives. Okay. This is what's so cool, all right, about derivatives. We know how to take what is known as a first derivative, right? So that was our y prime, our dy dx, all of those notations, okay? Well, there is something known as a higher order derivative, a second derivative, and its notation is y double prime, or, okay, the second derivative of y with respect to x 2 times. Okay, so notice the 2 goes in a different place on the top and bottom. Okay, so that notation is a little weird. All right. A third derivative. We might write it as y triple prime or d cubed y over dx cubed. Right. Now, we don't really want to get to where we've got, let's say we wanted a 15th derivative. You could do that. I don't have space for 15 slashes, nor does anybody want to count those, okay? So when we have higher order, we will write it as y, and it'll look like a power, but it'll be in parentheses, okay? That's the clue that it's a derivative, okay? And so whatever n is, it's 15, 27, 921, okay? Whatever it is, all right? The other notation, it would be dny over dx to the n. Okay, so whatever that number is. Now, just thinking about what we know about derivatives and some of the oopses you saw me do this week, how do you think we go from the first derivative to the second derivative? Any thoughts? we take the derivative of the derivative. We just continue to take the derivative of the previous answer, okay? So to do a higher order derivative, we just continue taking the derivative of the previous derivative. So it's really not, the thought of doing a higher order derivative is not hard. We just continue to take a derivative, okay? You have to do all the ones that come before it, all right? But that's all it is. The only problem that happens is sometimes the algebra gets really gross, depending on what the function looks like, okay? So what I want us to do is we're just going to practice a few higher order derivatives. I want to show you a couple of ways that they could ask us questions. How does it look when it's implicit, okay? And then that's it. Okay, we'll wrap up our Halloween. All right. Anybody trick-or-treating tonight? No? Sometimes people with younger siblings go trick-or-treating.
Oh, I'm doing that.
Yeah, yeah. One of our former students, her little boy is, I think he's 3 now. Looks like a sheriff's deputy. He looks like a legit police officer. He is so stinking cute. I was like, that is the cutest thing. Little badge, little holes. I mean, I'm just like, oh, let's eat him up. He's so cute. Okay, so here we go. We want to find the first 4 derivatives, okay? Typically when I'm doing a derivative, I use prime notation just because it's easier, all right? So if I take the first derivative, y prime, of x cubed minus 5x squared plus 2, what would I get?
2x squared. Wait, 3x squared.
3x squared minus 10x, okay? So then we want to do the second derivative. So y double prime, and we're just going to take the derivative again. You need to label your derivatives appropriately, okay? Don't just put a bunch of expressions down, all right? Derivative of 3x squared. And derivative of 10x minus 10. Our third derivative, 6, okay? Our fourth derivative, I'm not going to put primes, I'm going to use that other notation, okay? And what's the derivative of 6? 0, okay? There are your first 4 derivatives, okay? So you just continue to take the derivative of the previous answer. Not so bad, okay? Not so bad. So see if you can find the third derivative of that one. Give that one a whirl. Any of y'all giving blood today? Okay.
That's all we need.
Yeah, I'll do it. I try to do it at least once a year. My dad has one of those blood types that they need a lot of, and so he tries to do as often as he can. I'm A positive. The only reason I found out was because I gave blood, and it comes back on your blood, and you're like, oh, okay. I can't remember what Becca is, but she's whatever Denton is because she's not A positive. So. Okay, so here we go, rock and roll. We'll start with y prime. Did you get 8x cubed minus 5 plus cosine? Okay. Y double prime, 24x squared minus sine. Okay. Y triple prime, 48x minus cosine. There you go. Okay, good job. All right. So now, let's make it interesting. Yeah. Can we just leave it? Like, Miss Moore, it's that sucker you talk about. You're going to hit us over the head with it. Okay, here we go. That's why I didn't buy you blow pops for today. Wow. All right. So, but we only want a second derivative, okay? So let's talk about why this one's going to get a little complicated. When I do y prime, derivative of 2 secant. Yes, 2 secant x tangent x, all right? And then the derivative of e to the x, e to the x, okay? Now, when I get ready to do this second derivative, what am I going to have to use on this first part? Product rule, okay? We're going to have to use product rule on this first part when we do this second derivative. So, here we go. First, so 2 secant x times derivative of the second, what's the derivative of tangent? Secant squared, plus second, so tangent, derivative of the first, which would be 2 secant x tangent x. All right, so that escalated quickly, okay? And then the derivative of e to the x. Praise the Lord, okay? So e to the x is e to the x. So let's simplify a little. There's not going to be a lot we can do right here. Okay, so y double prime. This would be 2 secant cubed. This is going to be 2 secant x tangent squared, because there's 2 tangents, plus e to the x. Y'all, there's nothing else we can do. Okay, we don't have a term that's common to all of those, so we're done. All right, so the product rule was the tricky part in there. This is where organization is so important, because you can get lost in all the things that are on your paper. Okay. All right. So let's look at the next one. Okay. Again, we want to find the first derivative and the second derivative. All right, so let's start with dy dx, okay? Looking at this expression, all right, I always like to think, is there a way I could simplify this before I start, all right? Because if I can simplify y, it might make my life a whole lot easier, okay? Otherwise, I'm going to, because when we do quotient rule, we end up with another quotient. So we'd have to do the quotient rule twice, all right? So the thing I notice is that I have a difference of 2 perfect squares up there on the top. All right, I have x plus 4, x minus 4. Nope, x plus 2, x minus 2. She can be taught. Over x plus 2. Okay, and so then what's going to happen with that expression? Yeah, the x plus 2's cancel, and I get just x minus 2. Okay. So what is the first derivative? And what is the second derivative? 0. Okay, so you always want to look for, can I make this easier on myself? Okay. All right, rock and roll. Okay, so now we're going to do one with implicit. Okay, finding a second derivative with implicit. And they will ask you to do this. Okay, I'm pretty sure one of your pre-response questions on this test is doing this. Okay, so just as a heads up, you know it's coming. All right. So we're going to do implicit differentiation, which means we have to find dy dx, and then we're going to find d squared, the second one. All right, I don't want to say all that. All right, so here we go. Let's take the derivative. Good news is that our initial implicit is not anything crazy. Okay, so here we go. What's the derivative of y squared? 2y dy dx equals, and what's the derivative of 7y? And a dy dx, and the derivative of 4x, 4. Okay, I'm going to pull all my dy dx terms over, so that's going to give me 2y minus 7 dy dx is equal to 4. Right? And then I'm going to divide by 2y minus 7. So dy dx is 4 over 2y minus 7. Okay? So do we agree with that? Okay. Now, before I take my second derivative, I know that I could also write this as 4 times 2y minus 7 to the negative 1. All right? So that I could avoid the quotient rule. Okay? So I'm going to pull that up just because I can. All right? Now, we're going to have to think about it all as we do it. So now that I have dy dx, I'm taking the derivative of dy dx, which would be this new notation, d squared y dx squared. Okay? Equals. On the other side, that's going to be chain rule. All right? Which means I'm going to need the derivative of the inside. What's the derivative of the inside going to be? 2 with a dy dx. Okay? Times the derivative of the outside. The derivative of the outside is going to give me negative 1 times 4, which is negative 4. What's my power going to go to? Negative 2. And we're going to keep that 2y minus 7 in there. Okay, so because we did the derivative of the outside, all right, we're good. Now, let's simplify just a smidge and see if we can get this somewhere nice. Okay, so this is going to give me negative 8 over 2y minus 7 squared and a dy dx. All right. Now, here's the tricky part. We can't leave that dy dx in there. We want something in terms of x and y. But do I know what dy dx is equal to? Yeah, we already did that. All right. So what we're going to do is we're going to plug this in over here for that dy dx. Okay, because we'd already found it. So now I have dy dx, or d squared y dx squared, is equal to negative 8 over 2y minus 7 squared times 4 over 2y minus 7. So my second derivative, if I simplify that, negative 8 times 4 would be negative 32. And then I have 3 of those 2y minus 7s, so to the third. And that is my second derivative. Okay, so you always have to remember, if it's implicit, you're doing a higher order derivative. Okay, so make yourself a note. Plug in the first derivative into the second derivative to simplify. That's the mistake I see most people make, okay? Is they don't go back and they don't plug it in. Right? All right, I want you to try that one below it, okay? It says if x squared plus y squared is equal to 25, what's the value of the second derivative at the point 43? So we're going to actually evaluate it, plug in a value once we take the second derivative. So try that one. That's a circle. Yes, it's still the same, yes. Yes.
I don't know. I'll wait.
Yes, it is. You just have to be sure that it mathematically matches, but yeah, that's good.
On this one, how did when we do the how did it become a negative 8?
Because I had a 2 and a negative 4 that I multiplied together to get negative 8
Oh,
when I took the derivative.
oh,
Yeah.
oh, my bad.
Yeah, you're good. Okay, so here's what I see. We do really good on the first derivative, and then things fall apart a little bit on the second, okay? So let's start here, all right? So if we do this one, 2x plus 2y is dy dx, move the 2x over, and then those 2's reduce. If you can reduce, you should before you take that second derivative, okay? It'll just make your arithmetic nicer in the end, okay? So now let's do the second derivative. So d squared y dx squared, this is going to be quotient rule, okay? So d high minus high d ho over ho. Okay? So using that quotient rule, there's a lot of negatives here. There's a lot of things going on. So I've got d squared y dx squared equals a negative y plus x dy dx over y squared. Now, I am going to put that dy dx back in. So that gives me negative y plus x times negative x over y squared. Because this is multiple choice, all right, and all they want me to do is to plug in an ordered pair, I would not simplify any farther, okay? But I want to show you the simplification because there's going to be a time where they want you to, okay? So if I keep working, that's a negative y minus x squared over y divided by y squared. That is a complex fraction, okay? In order to get it to just one fraction, right? Because right now I got a fraction on the top. They can't go together, all right? Let's start by just getting one fraction on the top. To get one fraction on the top, they'd both need a denominator of y. So I'd have to multiply on the top and the bottom of that one term by y. So that would give me negative y squared minus x squared over y. So that's just the top, okay? I'm still going to be divided by y squared. Well, now when we divide two fractions, we keep the first, so I'm going to keep the top, and I'm going to multiply by the reciprocal of y squared, which is 1 over y squared. So in its simplest form, this is negative y squared minus x squared over y to the third. There will come a time where you have to simplify that algebra, okay? So I wanted you to see it. Okay, so you have to get a common denominator on the top, put that together as one fraction, and then keep, change, flip. Okay, so you're going to have to do some of that. All right. Now, to answer our question, we want the actual slope at an ordered pair. Okay, so we're just going to plug in the values that they gave me. So what were the x and y values? 4 and 3. Okay, so I'm going to plug in 4 and 3. How I would show that if I was having to show my work, it would look like that. We would put that bar next to it and then the ordered pair at the bottom. I'm plugging in 4, 3. Okay? And so that would be the opposite of 3 squared minus 4 squared over 3 to the third. All right, so negative 9 minus 16 over 27, negative 25 over 27. All right. Is that one of my answer choices? Okay, good. Okay, yeah, so that should give us A. All right, so be sure you've got all of that down. All right, because I want you to have that in your notes to go back and look at the algebra. All right. I've said it once and I'll say it again. The algebra is the worst part of calculus. It just is. Okay? All right, what questions do you have? That was just kind of it kind of covers everything we've done kind of all in one lesson, which is nice, knowing all your formulas. Okay, so that was A. Okay, so that's it. Let me give you some practice. This is on a bunch of different pages because your textbook throws higher order derivatives in the whole way. So don't panic. It's still not many problems. On page 130 and 131, we've got 33, 35, and 56. Okay. On page 152 to 153, we've got 39 and 48. On page 165, we've got 29 and 31. And then on page 176, 27 and 29. Okay, there is a wrap-up today that you need to do, so be sure and take care of that. And then we had one on Tuesday, and then we had one yesterday. Okay, so you had 3 wrap-ups this week. So Tuesday, Thursday, and Friday. So be sure you get all of those done. Okay, so you get those points. All right. Next week, here's kind of what the schedule is going to look like for next week. We're going to review Monday and Tuesday. Nope, Monday we're going to review. Tuesday you have no school. Okay, it's an election day with no election. Wednesday we're going to review. Thursday I'm going to be out, but you're going to take your test. Okay, so you will take your test. Y'all know what to do. Okay, and then Friday we will do test correction. So I will come back by and pick up your test when I get back from the doctor. Okay, so that will be next week. All right. The AP Classroom stuff will open on Monday. Your progress check, it's only 1. Okay, because this was a shorter unit. And it'll be due Friday at 3:15. So, and you'll have an extra day in there to kind of review on your own. So that's why I only built in. Okay. All right. Anybody get a perfect score on their ACT?
You did not.